Sarah Cross from Plant and Food Research in Hamilton, and she'll be talking on monitoring Varroa infestation, washes and sticky boards. What does it mean? Sarah Cross, Plant and Food, welcome.
Oh, cool. Yep. Good afternoon. My name is Sarah Cross. I work at Plant and Food Research. I am a research associate and also the apiary manager. So we run a semi-commercial outfit, and our hives are used for research purposes, for pollination trials, for queen rearing, Varroa research. And so this autumn at Plant and Food at Ruakura, we did a trial to see if we could find a correlation between sticky boards and alcohol washes. So we all know about Varroa, which is, of course, is a parasitic mite that feeds on the pupae in the hive. With that Varroa mite, it is a vector for spreading viruses in your hive. It will weaken the hive, and with no treatment, it will sadly kill your hive. We as New Zealanders spend thousands of dollars every year on Varroa treatments, so it would be really fantastic if we could find a way to not only control them, I mean obviously that's what we're doing, but we need to realise that we need to monitor our treatments and monitor our hives to make sure that what we're treating and what we're doing is actually working. So our Varroa monitoring here in New Zealand, we use it for, if you're not just doing straight calendar treatments, we need to monitor so that we can know what threshold limits we're at, to know when to treat. So another reason that we do Varroa monitoring is if you have an integrated pest management system in your apiaries. Also, if you're using any unproven methods or trying new things, like whenever you try something new, you've always got to make sure to monitor it to see if it is actually having a positive result. So it's one of the things we use mostly for research is an alcohol wash when we're doing monitoring. And an alcohol wash is where you take approximately 300 bees from the brood area, wash them in alcohol, shake them vigorously, and tip out the Varroa. So then you can count not only the Varroa, but actually all of the individual bees. And so this gives you a rate of Varroa per bee for your whole hive. Another way that people use for monitoring is sticky boards. Sticky boards are put in the bottom of the hive, Varroa fall, either from natural mite fall or while you're doing a treatment or before and after. The problem we see is that number of Varroa on the sticky board, it's sort of an arbitrary number. It doesn't actually tell you how much Varroa is still left in your hive. So one of the questions is sort of like, why would you choose a sticky board when it's not really giving you that sort of number? But of course there's other issues to deal with, such as the fact that you have to kill 300 bees if you do an alcohol wash, which is obviously a little bit tough for some of us. When you use a sticky board, it's obviously a lot less invasive, but also it's a lot quicker to do. You just have to put it in, take it out, rather than opening the hive and things like that. So the problem with the monitoring there is that, yes, it might be easy to do and you don't kill any bees, but the information itself is not very informative. So we designed a trial to see if we could find a correlation between the alcohol washes and the sticky boards. So we did a trial at Ruakura using 62 hive colonies. We put a sticky board in each hive, took it out after 24 hours, did that for 3 consecutive days. So that gave us 72 hours of natural mite fall. So there's no treatments in there, just natural mite fall. And on day 3, we also did an alcohol wash. So out of that, we've got 2 lots of data there. We've got the rate of Varroa per 300 bees, and also the natural mite fall on the sticky board. So that's the same time frame. We also did at the same time a cluster size estimate, which is to quantify the colony's actual strength. So it's a bit like the bee part, like when you do a pollination strength test. You just pop the hive, have a quick look at the bees clustering there, and give it a number based on how strong or how weak it is. So now we've got 3 points of data. We've got the rate, we've got the natural mite fall, and now we have a cluster size estimate as well. So if we have a look on the graph, if our results are going to go onto here, so you can see our y-axis is the rate, is the mites per 300 bees, and our x-axis is the collective, the cumulative sticky board counts. So that gives us a 72-hour full. So if we put this isn't the results, this is just to try and read the graph. So we're saying that if you had a sticky board in there for 72 hours, you took it out, you counted the mites, perhaps you counted 30 mites. Can I laser this? If we counted, here we go. So if you counted 30 mites, you could take that straight up and see that that would correlate to 9 Varroa per 300 bees. So then you could then make a decision on thresholds if you felt that was good, bad, whatever. You have to read whatever your research is on that one. But the thing that we did find is that when we put the data on there, we realised that the cluster size really affected the data. So if you look at number 3, that means quite a weak hive, and number 10 means quite a strong hive. And so if you had the same number again, if you counted 30 Varroa on your sticky boards, if you had a really strong hive, it would only be, 3 mites per 300. But if your hive was really weak, that again got all the way up to sort of 9. So again, that would be different decisions on your threshold limit of what you decided was your threshold limit for your hive. So if we go back to our original table, I mean, everything is still the same. The only thing we've added there is a cluster size assessment. But the thing is, the information that we can now get from the sticky board is more than what it was before. So again, it's still non-invasive. We still just have to put it in the bottom. We don't have to kill any bees. And the fact is, we might actually get a little bit more information than what we did before. Now, obviously, this has only been done once. This is very new. There was definitely some limitations. The first of all, of course, was human variability. Someone in our research was the one who opened all the hives and did the cluster assessments. Now, we only ever used one person, because obviously it's still an estimate, and my estimate might be a little bit different to your estimate. And so that's how we knocked down the variability on that one. And regardless of who does the cluster size estimate, it's still going to get the same trend, that same upward trend. So it just sort of depends on your like say, your cluster size estimate. So for the future, we definitely have to repeat this, hopefully on more colonies. We're definitely going to use a different size estimator to see if like I say, the trend will still be the same, but it's just more about how much that might change. And you have to remember, we didn't take into account, this is only a snapshot in time. This was autumn at Ruakura in Hamilton, 2 different apiaries. So we didn't take into account things like the amount of brood, the hygienic behaviour of some bees are different, even different seasons, which we know can change, especially if it's determined on the cluster size. So all the future things that we are planning on doing. But the good thing is that hopefully, because we have this trend, hopefully we can find a more non-invasive way of monitoring our hives, so it's easier to do, so we can get that threshold level and make sure we're treating and hopefully trying to lessen the amount of hives that are dying from Varroa in New Zealand. So that's our plan. Thank you very much. Oh, any questions? You have to use the microphone if you would like to ask a question.
Just to ask, we did an extensive sugar shaking exercise this season, and we did over 900 shakes, over about 1,500 beehives over a 3-month period, trying to quantify what the acceptable rate of Varroa is before it starts to impact. Now, Randy Oliver's estimate is 3 to the colony. Now, we had a huge variety of strengths of colonies, brood, placements, X, Y, and Z, and we're obviously using the 3 mites per 300 bees on a sugar shake as an estimate. Obviously, you know, there's only 70% success or drop rate on the powder. What, from your experience, have you got a guideline for New Zealand now when to treat? Because we're still using the 3, but we found that 3, we've treated hives with synthetics and oxalic throughout the whole season and kept the count to 1 and 2, but you've had to treat all the time. So just some thought on that.
That's the thing, I can't answer that. I mean, in New Zealand, because of the obviously the threat of resistance and all the other things that are going on, there's not I mean, the thresholds that we did, when Varroa first came in, will not be the same now because of the changing resistance and the things in our environment. So I cannot give you an answer for that one. That was the thing. I didn't really want to put on here, here's a line where you have to treat. I mean, like I say, geographically and environmentally, it's all changeable. And the scary thing is the resistance part, and it is changing. I can't give you a definite answer on that one. But yeah, it's the future. He was just saying it would be fantastic if we made a standard, and so that when you are treating your hives, this is the New Zealand standard, and this is when you have to treat. That's what that gentleman said, which is a fantastic idea, but out of my pay grade.
Just wondering if you've used the CO2 method from Swente, a little gas thing that knocks them unconscious and the mites fall down.
Oh. Well, we do use CO2 for some of our trials if we need to knock them out, but not for the Varroa.
Yeah, it's a product by Swente which we've got, but we haven't tried it yet. But yeah,
I would point out that there is some research saying that when you CO2 them, their behaviour changes a little bit once you put them back in the hive. So
okay.
I would.
The other thing is the alcohol wash. What's the proportions you use exactly? Is it isopropyl alcohol?
Yeah. We usually use a high grade sort of 99%.
Okay.
Like straight up. Yeah.
Thank you.
Yeah. And remember, that's always, so when we count them, it's always a 300 bees. Like it's which by the way is half a cup. Learned that the other day. So half a cup of bees. Measure them out. Yeah. We're okay. Thank you.